Let's look at configuring a firewall. And I have some virtual machines set up in my lab that you can use. First thing we need to do is to connect to my lab. And for those of you who had the first class, the 482 class, you'll already have this connection. For those people that are new, I'll post the instructions on how to do this. Username CIT user, same thing for the password. And if you get these messages, everything's going according to plan. So after you connect to the lab, you'll open up a remote desktop connection. And I'm going to connect to 192.168.107.101. You can use any of the computers we used for the Metasploit exercise. Now, before I click connect here, there's a couple things I want to check on. If I clicked on options there, I want to make sure that my display is all the way to the right here, so I get a full screen connection. Then I'm going to click on local resources here and go down to local devices and resources and click on more. And I have already configured this. I expanded the drives here and then put a checkbox here in the box beside a local disk C. And what this is going to do, this will it will make my local C drive visible on the remote machine, which means I can save files from the host operating system I'm connecting to here back to the computer I'm actually sitting at. Now, there's another step that you have to do to save files from the virtual machines, but that's I've covered that in a different video. So click on connect. You get a little warning here, and you get this because you're sharing drives. I'm going to connect anyway. Here's the user account I want you to use. Firewall setup, all one word. Password is capital P, lowercase ASS, and then the letters, or the numbers, excuse me, 1, 2, 3. So now we're connected to one of the servers in my lab, and now what I want to do is open up VMware Workstation. Now here you'll find there are 3 virtual machines that have been suspended. There's a Windows XP. I'm going to go on and start it up by clicking the little green triangle. There's another one called Smoothwall 3-Polar. This is actually the firewall. This is this is the free version of the Smoothwall firewall, which there are commercial versions of. This is Smoothwall Express, and it's what we're going to be using for demonstration purposes here. So briefly, I'm going to go back to the Smoothwall, and let me click inside the box here, the window. Yeah, here it is. This Smoothwall is running on a stripped down Linux distribution. I can't remember exactly which one they're using, but if you have any familiarity with Linux, you would be at home if you actually dealt with the firewall directly. Now, we're not going to deal with it directly, at least not yet, and I'll show you what we're going to do here in a moment. So just to give you the setup here, The Windows XP machine is on the public side. This will be on the internet side. And then comes the firewall. And then the server 2003 is on the inside. This is the private side. So here's what we're going to do. I'm going to go full screen on the server. And remember, this is the private side. Control-Alt-Insert will give me the logon box, and administrator's password is, of course, capital P ASS 123. Maybe it is. Sometimes here I get some strangeness from my keyboard. Let's see. Let me put it there for the time being to see what I'm, yeah, that's what it is. Let's see, function scroll. And now let's try that. Yeah. I'm using a tablet, and there's a lock, keyboard lock on it that will basically turn on the embedded keypad. And sometimes when you're using remote desktop, it turns itself on, which is usually not what you want it to happen. So I'm going to close this real quick, and let's see, I'm going to close this too. I've been in here working and I forgot to do my housekeeping. So this is probably the way you're going to find it. There's a command prompt open, and it's not a big deal. Probably the first thing I would do if I were you is I would do a little basic connectivity testing here. This is what I've been doing. If I ping this IP number, this is actually the IP number of the XP, which remember is on the public side, the internet side. So if I press enter, from the inside I can ping through the firewall and out to the XP. Now let's switch back to the XP side and see what we can do from there. And you may or may not have a command prompt already open. See, it's locked in again. Let's see. There, that should do it. And now all I have to do is spell it correctly. Ping 192.168 58.128 is the IP number of the internal server. So I'm going to press enter here, and I get destination port unreachables. Well, think about this. We're on the outside going in, and there's a firewall there, so these packets are not making it through the firewall, at least not at this point. Okay. And another thing we can do while we're out here is we could open up our scanner, and notice here I have it set up to scan 192.168 58.128, which is the number I pinged. So I'm going to start a scan here, and I've got it set up to do all ports from 1 to 81. We might change that later, but that's going to be okay for now. The X means that it didn't answer a ping, which we already knew it wouldn't answer a ping, or we couldn't get a ping through. That's not exactly the same thing as not answering a ping. So our scan from ports 1 to 81 is finished here, and no ports were found to be open. And again, that's because we have a firewall in the way. So this is on the outside. Let's go back to the server now on the inside. So what we proved here is, so far from the outside we can't ping the internal server, and we haven't discovered any open ports on the internal server because our firewall is blocking everything. So I'm going to go full screen here. Now, I told you a while ago we weren't going to configure the firewall directly, and here's how we're going to do it. Here's how we're going to configure the firewall. I'm going to open up Internet Explorer here, and I'm going to type in http://192, and probably as soon as you start typing 192, you're going to be given your history here is going to show you some IP numbers. As soon as I find my mouse, so I'm going to pick the top one here. Now let me show you what's going on here. Look at this right here. The internal network is using 192.168.58.0. The internal interface of the firewall is 192.168.58.2. And in this case, the :81 is used to indicate TCP port 81 on the internal interface of the firewall. And this is where a web server is running on port 81. And this is what we're going to use for configuration purposes. So as soon as we clicked enter here, we got a little connect to dialog box. And here you want to use the username admin, and the password is happy days, all one word, all lowercase. I'll include this in an email. Click OK. Now here we have the management interface for the Smoothwall Express firewall. Now I'm sitting at the server connected to the internal interface of the firewall, and I'm going to configure the firewall through a web interface. And this is pretty much a very common thing of how you can manage these devices. And there's a number of things here, and I don't know how many of these we're going to get to eventually. I'm going to start here with under networking. I'm going to go to incoming. Now, here's where you'd enter rules to forward ports from your external IP address to ports on machines inside your local network. So not only is this going to be like a firewall, but it is a firewall, there's also going to be some network address translation going on here. So port forwarding is the terminology we typically use with a NAT server. Now, I always have to play around here to get the syntax right of a new rule. The protocol is going to be TCP, and what we want to do here is I want to open up a hole in the firewall for web traffic. So the source port or range, if you think about this, is going to be the high numbered TCP ports. And the destination here is going to be 192.168.58, and the web server is at 128. And here, the destination port is going to be HTTP. And let's try adding this and see if it likes it. I keep forgetting the syntax. I think we're okay. So here's our current rule. Protocol TCP. All source IP numbers, because we didn't specify anything up here. And initiated from a high numbered port. And that's 1024 on up to 65.535. This will be forwarded to the destination IP 192.168.58.128, port 80, destination port TCP, port 80, and that's typically where a web server would would be listening if the computer is running a web server. So we've added a rule to do port forwarding, or in essence to open up a hole in the firewall. So now let's switch back to our XP Pro. And I'm going to run the scan again. So I just click on Start. We still didn't get a response back to our ping. But now notice we're showing one open port. When we expand this, you'll see that it is actually port 80. So that's how you would open up a hole in this particular firewall. And also remember, we're calling this port forwarding in this case. And the terminology is going to differ slightly from one product to another, and how the rules are entered will definitely be different from one product to another, but the concept's going to be similar here. I was wondering what we could do next here. Let's I'm going to take this rule out just temporarily. I'm going to go back to my XP. Let's run Wireshark, and so we can see the packets, see what's really going on here. Now again, I'll mention to you that when we're doing this, when you're testing out your firewall, you don't typically have to use Wireshark. Just like when we were doing port scans, you don't have to use Wireshark. I'm just having you use it so you can see what the packets look like, because I think you learn a lot by looking at the packets, and that's why we're using it. So I'm going to set up a capture. Now notice out here I'm on the public side, and actually I think I'll set up a capture both ways. And I clicked Start too soon because I'm on the generic interface, which won't really do anything for me. So gonna go to Capture and then Options and pick the correct interface. I want the VMware Accelerated AMD adapter, and I'm going to clear the checkbox on promiscuous mode. It's not going to do me any good. I'm going to put this on update list of packets in real time. You can leave the capture filter if you want to. It's not a big issue in this case, since we're not directly connected to this virtual machine. We don't have the remote desktop traffic showing up on this particular interface, so it won't hurt to leave it in there. So I'm just going to start that. And maybe we're going to get too much Microsoft generated traffic. I think I clicked too many times there. I want to go back to the remote desktop. Come back over here to the server side. This is the private side. I'm going to run Wireshark over here too. And I'll show you the difference in what it looks like from one side to the other. Options. Again, I want the VMware interface. Clear that. I'm okay with everything else. So start this. Now I'm going to switch back to the public side and go full screen so I can get to my scanner. And remember, we closed the hole. So I'm going to click on Start here and let it do another scan. Remember, the firewall's back to its original condition. we're finished. I'm going to click on stop. Now, back here to Wireshark. Notice here we send out, there's a ping request here that was not answered. And notice we get, let's start with this packet right here. This is an ICUMP destination unreachable, port unreachable packet. If you expand the Internet Control Message Protocol part of this, if you expand it, it will contain the header information for that triggered this response. So this is what I'm doing now. I'm scrolling down and opening up. So this particular, this packet number 5, the ICUMP destination unreachable, was in response to the ping request that wasn't answered. Packet 6 is the start of the port scan. It's the send packet being sent to TCP port number 1. If you look at packet 7, this is the ICUMP destination unreachable. It's being sent back from the firewall. The public interface of the firewall is 192.168.20.2. So this is coming back. This is actually the packet, the send packet being sent to port number 1. So you can look at these destination unreachables, and if you look down inside of the packet, it'll tell you what previous packet triggered this response. So that's interesting. And if you look through here, you'll see that we get a lot of destination unreachables coming back. We don't get a destination unreachable coming back from every port that we scan, however, and I don't know why. And I have been looking around trying to figure out how to turn this off. You know, tell the firewall not to do this, because it's just a good practice to not have your firewall give back any kind of information. But it does, after the first few packets, it does get to be pretty regular. You'll have 4 packets, and then you'll have 1 destination unreachable. You'll have 4 more packets and 1 more destination unreachable. So I'm not sure what's going on there. Anyway, there's this is, again, nothing went through. Notice here, this is the packet for the port 80, the web service, and it didn't make it through either. So this is on the public side with no holes in the firewall. I'm going to switch back now to the private side, again with no holes in the firewall, and all we have captured here is a bunch of the NetBIOS name service packets that Microsoft operating systems generate these kind of at random. They're very chatty, but there's nothing here that has anything to do with the scan that we just got through doing. So let's set everything up again. Let's go back to our web interface here, and we'll put the rule back in. So again, TCP is our protocol, high ports, and the destination IP is 192.168.58.128. That's our destination IP number. Our destination port is HTTP, which is port 80. So we click on add. So here's our rule, back just like it was a few moments ago. Let's go back and reset our capture here. This is interesting. Which side are we on here? Okay, we're still on. Where all the traffic came from? Oh, that's interesting. Yeah, as soon as the capture was still running, and as soon as we started using the web interface, notice this is all between port 80, 81, and a port on 128. This is all the traffic, the configuration traffic. So that'll be okay. We're not going to be configuring while we're running our scan, so it will not interfere with us. Okay, start without saving. So I'm going to switch back to the public side. Go full screen. I'm going to again. What I want you all to do is actually save this. But I'm going to go on and start mine. Continue without saving. Go to Super Scan. Run the scan again. And while this is running, I'm going to go back over to the server side, the public or the private side, and see if we're connecting or we're catching anything. Interesting. All of a sudden we have traffic. Let's look at it. Coming from 192.168.20.128, which is the XP machine, going to the server 192.168.58.128, we have a TCP protocol. We have something, and again, it's mapping this port here to something that other people use. This is actually port 2408, and its destination is port 80. Notice right here. So this came through the firewall, and here's the response going back, the send ACK packet. Here's the final ACK. This is the get or head request packet coming from the XP machine to the server, and this is a response from the web server. And this is another, well, this is the ACK packet from the XP, well, actually the scanner on the XP, and this is the reset that basically shut down the connection. So these packets here, and we got a couple ARPs in the middle there. These packets here are actually showing the traffic coming through the firewall. So that's what made it through. And go back to the public side, and we can stop our capture there. And just like we had a while ago, these are all the packets that were generated as part of the scan itself. And again, the only thing that got through was port 80. And if we scroll on down here to the end, we'll be able to see the traffic coming back through the firewall since we opened up the hole. See, there we go. Let's see. This is the send packet. This is the send ACK coming back from the server. This is the final ACK packet. This is the get request, the head request for the web page. Here's information coming back from the web server. So these packets here they match what we captured on the inside, and it's all because we opened up a hole. So what I want you to do is I want you to save these. And I made another video that explained how you can set up sharing See, notice here I've got VMware shared on host. So what you see here, this is actually on the host operating system. And not only that, once you get it to the host operating system, you can go in and move it back over to the folder on your local computer that you're sitting at. It'll be a two-stage process, but it's all doable. So make sure before you start, make sure this is set up. And again, there's another video on that. So here, give it a file name. This would be, put your name on it. I'm just going to TP mine. This is public HTTP open cap 1. I always number my caps in case I'm gonna do it again. Next time I did it'd be cap 2, so I can save that off. Notice I've changed the time format here, and again the other video that I made kind of explains to you how you can do this. This will put in the date and time as understood by the operating system that did the capture. So what I want you to do is I want you to save a before and after opening up holes on both sides of your firewall, and then we'll have some exercise on commenting on what you're seeing. Let's see, I had another thought there. We're going to open up another hole or two. I'm going to close this down and get ready to exit here. One thing I should have told you on the beginning, you can on your Smoothwall here, I have a snapshot. Now the problem is if you revert to your snapshot here, even this one here I've been playing with, it has one that says clean install time set. Well, the problem is if you roll it back to this time, or this clean install snapshot, it's going to revert to the time when I set it right here. Now we're going to have problems with the time on the firewall because it is we're suspending it between times. So what you can do is you can revert to a snapshot of the the clean install, and then over here on the server, when you connect to it, and I'm going to close this off. Close this out. It's going to fuss at me because I need to save this, but you need to save it, but I'm not going to. Let's see, somewhere in here you can set the time from here. Tools, shell, I think it's under maintenance. Maybe it's under services. Yeah, under services, time. So what I'm saying is here, before you start, roll back your firewall to where it says clean install, and then on the server, connect to the management interface of the firewall, go to services and time, and set your time. And it usually takes a couple of attempts to get this right. You have to pick your time zone, which is way down at the bottom, Eastern, U.S. Eastern, or you may be in Central. And then set your date, your time here, date and time here, and click save. And if you want to, after you do this, you can go back to your the firewall, and at the command prompt here, if it's not logged in, you can log in as root, where it says username, type root. This one's already logged in, but you type root, and it's going to fuss at me here because I'm already logged in. and then the password would be, again, just like it is for the web interface. It'd be Happy Days. So anyway, once you log in, you can type in date, and it'll tell you what time and date it thinks it is. So this one's actually not in too bad a shape right now. But anyway, that's one of the things you always want to make sure is that as much as possible you want your router and your firewall and indeed all your computers to have the same time, because if you start tracking something that happened doing some network analysis, the closer the times are on everything, the easier it's going to be to correlate logs on one machine with something that happened on another machine. So that may be something, or that will be something you want to check before you get started. Make sure your firewalls roll back and any other rules that somebody else may have put on it are removed, and your time is right. Figure out where my mouse is. So I'm going to complete my shutdown here. I'm going to go back into here. I'm going to go back to networking. I'm going to remove this rule I just put on. Remove it. And I'm going to shut this down. So now I've got everything back to pretty well square one. So what I want you to do is, in the first place, I'm putting everything back to the way I found it. I'm going to suspend these 3 virtual machines. But for your assignment, and I'll write this up a little better, I want you to go in and add at least 2 rules. I was trying to think how many services are actually running on the server. But really, it doesn't matter, does it? We can open up holes whether there's a service running or not. That's good. I'll write that up. I'll tell you what services to open up holes for, and then what I want you to do is I want you to do a capture on each side, public and private, before you open up any holes. And then we'll open up some holes with port forwarding, and then I'll have you do another scan and capture those, both public and private, and then we'll you can look at the differences with when the holes are open, when there's a service actually running there, when there's a hole open and there's no service running there, etc. So that'll give you a good comparison of all the different possibilities. So I've got everything suspended here. I'm going to close this. I'm going to log off. This will shut, not only log me off, it will close my remote desktop connection. And now shortly I'll be back on my desktop. Then you'll have to disconnect from the VPN. And I did forget to show you how to move your files around, but you should be able to figure that out.